Hello mathematicians, we're now going to have a look at expanding algebraic expressions. And you would be well aware, I'm sure, that expanding an expression just means removing the brackets. So how we do that depends on what the problem is at hand. But there are a few special expansions which you really need to know very, very well. They're not new ones for you, but they're perhaps ones that are not yet automatic for you. So here they are. The first one is the perfect square. A plus b all squared equals a squared plus 2ab plus b squared. Now this is a really common source of error by students beginning senior school. They take a plus b all squared and make it a squared plus b squared. Wrong, wrong, wrong. We need to think about why. So if we had a plus b squared, we know that that's a plus b times a plus b. And if we were expanding that out, we know it would be a times a, which is a squared, plus a times b, plus b times a, which is also ab, plus b times b, which is b squared. In other words, it's an a squared plus 2ab's plus b squared. Now, as I said, we need to know that really well. When we go this way, when we're expanding it, we need to know that, but we also need to train ourselves to recognize this bit, so that when we see an algebraic expression like that, we know that we could write it like this. So going this way is expanding, going back this way is factorizing. Now we've got the same thing for a minus b all squared. The only difference is that we've got minus 2ab. Again, you can work it out as to why that's the only minus. There's not a minus here, but very quickly that has to become automatic. We've also got difference of squares. So if you check this one, a plus b times a minus b, then this is just a squared minus b squared. So subtle differences, don't mix them up. So if we multiply them out, we've got an a times an a minus ab plus ba and minus b squared. So of course these two cancel each other out, and we've got a squared minus b squared. So let's have a look at some of these examples. Now, I'm not going to do all of them again, but they're there for you to practice if you wish. So I'll just do this one here. When we look at it, it's not one of the patterns that we had up above in terms of being expansion or a binomial squared or a difference of squares. It's just a multiplying out one. So when we do that, our 3x times 4x gives us 12x squared. Our 3x times negative 5 gives us negative 15x plus 32x and minus 40. And then we gather like terms. So we've got 12x squared, don't know why that's doing this, plus 17x, I'll try and get rid of that, minus 40. Okay. Out of our next lot of questions, I'll just work again a few of these. So if I look at this one here, I've got to recognize that that's something special. So it's the square of the first plus twice the product, so that's twice 3a, so that's 6a, plus the square of the second. So that's one that has to come automatically to me. The next one, when I look at that, I've got to recognize that that's two sets of brackets. They both have the same things, the only difference is the sign between them. And I've got to know that's a difference of squares, so that I can automatically write down c squared minus 2 squared, which is 4. I know you can work it out from first principles, you can multiply them all out. Likewise with this one here, you could write a plus 3 times a plus 3, but you're just not going to have time to do that. Let's have a look at h really quickly. So when we square this, we'll square the 4 and square the y. So 16y squared. It'll be minus twice the product. I'll come back to the twice the product in a moment. plus 5x all squared, which will be 25x squared. Their product will be 20xy, and twice that will be 40xy. And that's our expansion just there. Our last example here is going to probably be a little bit tedious, but it's good because it reminds us of a different type of problem, which you'll come across more of later in the course, which is to prove an identity. Now there's an equal sign in here, but it's impossible for us to work out what A, B and C actually are. What we want to do is to prove that this thing here is the same as this thing. In other words, we want to check that that equals is true, because it means what's on the left is the same as what's on the right. So there's a certain logic to this, and the logic is generally that you take one side and you work on it and try to see if you can make it into the other side. As a real rule of thumb, you take the more complicated looking side and try to work it into the simpler side. So if we take the left hand side and we'll just work on it. And the thing is that we often don't know exactly where we're going with this, we just follow a process. So the left hand side equals, I won't rewrite this, I probably should, but if I multiply it out, then I've got A times AB, so that's A squared B, plus A times BC, plus A times CA, which is going to be A squared C, plus B times AB, which is AB squared, plus B times BC, which is B squared C, plus B times CA, which again will be ABC, plus C times AB, which is another ABC, plus C times BC, which is BC squared, plus C times CA, which is AC squared, minus ABC. Now when we look at that, we've got an ABC here, an ABC there, an ABC there, and an ABC there. So that's 1, 2, 3 ABCs minus an ABC. So that will give us 2 ABCs. And we've got all of these other bits. A squared B plus A squared C, blah, 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 blah. So some attempt to tidy it up. So that gives us A squared outside of B, takes care of that one, plus C, plus B squared outside of A plus C. I'll just rub this out, put it back in a little while. So B squared outside of A plus C we've taken care of, and C squared outside of A plus B. And what did we say? Plus 2 ABC. In this case, it's not immediately apparent, at least to me, how that is the same as this. So in those cases, what I would do is now take the right-hand side and see if I can work it into this one here. So if we do that, the right-hand side equals, and I'll multiply things out. So it'll be AB plus AC plus B squared plus BC, that's multiplying the first two brackets, times C plus A. And since I'm running out of space, I'll keep going on the same line. So that will be ABC plus AC squared plus C, or B squared C I should write it, plus BC squared plus A squared B plus A squared C plus AB squared plus ABC. Now you can see there are my two ABCs, so that's looking good, 2 ABC. And what have I got in here? I've got an A squared outside of B plus C, So that's also looking good. So I've taken care of that and that and that and that. I've got a b squared outside of a plus c. So even looking better. And I've got a c squared outside of a plus b. So the right hand side equals the left hand side. Now try practicing your skills on 1b.